Hey, thank you guys so much for coming out.
So, apologies. You know how it is when you suddenly have to hook up some new technology. We punted, though, and we've got it. We were going to switch back and forth between laptops. Now you'll just have to watch us do some.
No, we'll still have to switch. We still have two. We have two instead of three, so we've consolidated. We've gone efficient for you today.
So,
and you're gonna have to push the actual button for the next slide.
Yeah,
maybe spacebar. Spacebar.
Welcome to our presentation, Blinded by TunnelVision. So this is digging into exploiting DHCP. This was specific to one thing that was mentioned, so we'll go through that. My name is Steve Fink, and I am the CISO and CTO of Security. Also, I'm the principal architect of the Black Hat Network. I work with this fun guy right here. And I'm also a free-range human. When your kids all grow up and go away, you get to do whatever the hell you want. And so we just wander around, move about every 2 years. So it's been fun.
And I'm Mike Spicer, also known as Dark Matter. On the interwebs, you might know me from such projects as the Wi-Fi Cactus, Kraken, wireless stuff. You might see me at the Black Hat Knock. I've been working with Fink and the rest of the team over there for the last couple of years doing stuff. They finally made me come over and actually work there instead of just hang out and steal all their data. And then also I do some cool stuff at Coalfire. I'm a principal there, newly started over there. So shout out to Coalfire and working with them. Was previously with Security, so shout out to Security, awesome folks over there. And then also I have a hardware startup called Apex Storage where I make super fast NVMe drives. So if you need 30 gigabytes per second read-write, come see me and talk to me. We can talk about some cool stuff.
And he means blazing fast.
All right. So first and foremost, most talks you go to, you're like, oh, hey, we're going to get to the demo in the end, and hopefully the demo gods will do it. Well, we're starting off with a demo from the start. So everyone who knows anything about VPN providers and things like that and TunnelVision and this vulnerability already, we do, in fact, have a access point that's already set up so you can connect to it now so you can help us test your VPNs, because we're still trying to figure out who's vulnerable. So go ahead and pull your devices out that you want to connect, that you've got VPNs on, and connect to it. Heck, your devices might already be connected. If you see a Starbucks, a Delta Wi-Fi, a Leahona, or something like that, you might already be connected. So go ahead and check your devices, and we'll get to that in a minute. Last
we looked, we had 15 unwilling participants. So this is your opportunity to either opt in or opt out.
Yeah, and I couldn't find my pineapple for some reason. I have a lot of them, and I couldn't find them, and ended up just building one out of a travel router running OpenWRT. So this is the pineapple for today's presentation. Okay, so first off, we got to get to the very base building blocks because we're going to be talking about some very, very basic fundamentals today. At the very basis of that fundamentals is the importance of network protocols and digital communications. So what are we talking about? This is the basic building blocks. We start out with frames, we have packets, we have encapsulation, we have all of these components. And all of these protocols make up what we see in the communication that's there today. A lot of these things were decided by consortiums and large organizations, the Internet Task Force, and were built from years and years and years. So what are some of those? Like DHCP is a protocol, for example. We have IP address, which does IP address allocation. And also it helps us assign addresses and make things easy. So that's the big one we're going to focus on today.
So today we're going to specifically talk about DHCP. So part of DHCP, actually a majority of it, was written in 1985. And we'll get into that a little bit more later. But let's break down the initial process of what happens when a machine comes on the network and it makes a DHCP request. So the acronym to remember this is called DORA. Just so
the Explorer.
Yep. Dora the Explorer goes on a network, and Dora wants to know what's up. So the discovery goes out. offer, request, acknowledgement. And they go in that order every time. So we have our router out here, just like the one we have sitting here. Unsuspecting client gets on the network and sends out a series of discover packets. Now, these discover packets go to every single node on the network. Based on the broadcast address, it just goes out. Doesn't matter who, everybody gets a copy. So then the router responds back with an offer. I have DHCP. I'd like to offer you some details about this network. Are you willing to accept my offer? And the client says, yes, I acknowledge your offer, and I would love to talk to you. And they start the communication, and then they starts the process of transferring those packets on the network.
So then, just kind of to summarize, we have this back and forth between the client and server, the door that's going on. It uses UDP, port 67 for the client, port 68 for the server, and it's typically in the same broadcast domain. So that means that it's going to be your local LAN. However, you can escape that with DHCP relays, as well as doing other things to get some trickery to go across broadcast domains. But mostly it's LAN. And so then the next piece of it is after you get a DHCP request, it fundamentally changes the way your computer communicates to everything there. It creates information as part of a routing table. So here's an example of a super basic stuff. I know we're in like networking 101 here. I see some of you falling asleep back there. Hang with me. We're getting to the really good stuff on the next slide. And so basically, it stores your route. You get that information. Your computer's like, okay, these are the computers I know how to talk to. And then we get into the
reading RFCs.
Who's ready to start reading RFCs with me?
Yeah. So we are really actually going to dig into this just a little bit. So I mentioned it was, most of it was kind of built in 1985. There were some updates after that. But when you look at these things, so this was part of it in 85, DNS. Everybody knows we need a DNS server on ours. But here's something more interesting. In 1985, built in DHCP is the ability to turn on and off IP forwarding. Think we could exploit that? Maybe in a later talk. So here's part of the conversation that can happen from DHCP is a DHCP release renewal. And during that, the client already knows something about the network. So it says, hey, I've had this IP for a while. Can I have it back? And this is how DHCP won't roll if this is properly functional and enabled on your network. So a few more other little things, TFTP servers, PXE boot, all of those, they're all built in there, but they come in somewhere in the mid-90s. 97 is really where we think it came, but it's somewhere right in there. There's a lot of back and forth on how it should have happened.
And then we get to the critical features. So like we were talking about, you're getting IP addresses, you're getting lease times, everything is all like nice in a cute little package. You've got your the IP allocation. It's going to be set for a certain amount of time. It's going to be from a pool. Typically, these pools are limited in scope and size. It simplifies your network management, so everything's going to be nice and easy for you. And no one needs to worry about it. Everything's just plug and play, right? Everything's all nice and easy for us.
Sometimes maybe plug and pray.
Yes.
Like today. So there are some critical weaknesses in DHCP on IPv4. IPv6 has some of these critical weaknesses fixed, and you can authenticate it better. All of our talk today is going to be specific to IPv4 and DHCP on IPv4. So we have no authentication. There's no encryption. We have vulnerability to rogue DHCP servers. It goes on and on and on. So the CVE that we're going to talk about is this CVE number here called TunnelVision. Now, Spicer and I were sitting at the RSA SOC when he came to me and he said, "Hey, man, did you hear about TunnelVision?" And I was like, "No, man." And we started talking about it. And this is where it was born. So at both RSA and Black Hat, we sit side by side. Depending on the venue, it's either left or the right.
We're sitting there discussing. I'm super excited. I'm like, all VPNs are broken. The world is falling. The sky's falling. We're going to do this to everyone that's at these conferences. Like, let's exploit this now. Let's figure this out. All the information hadn't come in. There wasn't any proof of concepts really that people have put out there. It was mostly just a vulnerability website that gets published, right? So immediately doom and gloom, everyone's freaking out and the sky's falling. So
one thing to remember is this isn't new. So it was built in 2003. In 2003, there was a report of manipulating it, 2017, 2018, so on and so forth. What is new is somebody created a CVE with a cool name.
And as a pause real quick, how many have joined our nice access point? By show of hands, anyone? I need some people to join because I'm not seeing any of your VPN traffic right now. I see 0. Oh, he's saying he did. I better refresh and make sure.
So let's take a look at the difference between our previous conversation on the network and one with TunnelVision. So we have our router. We have our unsuspecting guy. He sends out his traffic. But instead of it getting to the router, we got a little script kiddie. He's sitting in there in the coffee shop in the corner.
That's me.
And he's answering back faster than the DHCP server can respond. And he's providing the information to our unsuspecting client. And it's acknowledged and they establish communication. Now, we've done this for years. Spicer and I have done it. Oh, man.
Yeah.
I even tell you. But you establish man in the middle. So now you're in the middle of the conversation. So basically, it's side channel communications. We've done this for years. What's unique about this is the subversion of VPN.
And every YouTuber is like, hey, guess what? You're secure on the everything if you go get a VPN provider, right? Sign up for my NordVPN or my ExpressVPN, or here, use my promo code to get 10% off. And we might have a promo code for you at the end of this talk. Stay tuned. In summary, real quick here, just kind of going over the details of this attack. Fink went through kind of the logistics of how someone will do it. It's typically a local area network attack, which means that I've got to be in the same location as you. So that's why we were talking about coffee shop. That's why, you've got to be similar place. That's why it's interesting with like thinking about Wi-Fi pineapples, thinking about ways that you can man in the middle people to then decloak their traffic. It's exploiting the DHCP option 121. You have to have a malicious DHCP server, and then we're going to get traffic redirection, which is hopefully what we'll show you with our demo with some of our unwilling and willing participants in the audience. And then at the end, we're ultimately bypassing and getting some traffic leaks. So what does that mean? Well, this is a diagram of how the internet works without the VPN. As you can see, the computer goes to the internet, which has a modem router sitting next to the internet, with the internet next to the tower. So it just, ChatGPT is the best, or DALL-E's the best, right? Internet. So this is what, everyone knows what it looks like without a VPN, all right? This is what your internet looks like with a VPN, right? It's secure across everywhere, VPN on VPN. Anyway, sorry, this is just some funny things that I found. No, seriously, though, let's look at a trace route. Here's what it looks like with a VPN on this particular system. 10.100.0.1 is the IP address and the gateway of the tunnel adapter that gets established by the VPN client. As you can see, it's routing through, hitting out to Lumen. This was an example of trace route to yahoo.com. And then next, let's look at, here's an internet with VPN, but with TunnelVision. And in this specific instance, one of the things that you can do when you're establishing this attack is place routes inside of the computer's routing table. And in this instance, I chose a specific route for 8.8.8, and I wanted to make sure that's Google DNS. I wanted to make sure that that gets routed through that 192.168.8.1. And why would I do that? Why would I target and do that? Well, because routing tables give priority to the smallest scope possible. So the smallest scope possible will get you the highest priority in your routing table, unless it has a lower metric. So if your metrics are the same, it'll go based off of the net mask of the lowest priority, the least scope. which is an interesting development, and which is actually a mitigation that some VPN providers are doing. We'll get into that in a little bit. So now I'm watching all the DNS traffic, but now I want to watch all the traffic on the network. One thing that was interesting when we first started setting it up to do 0.0.0, if you did it with the net mask of /0, what was happening is you would actually get beat by the DHCP or the tunnel adapter for the VPN provider because it did a /1 as its net mask. So what's happening is even though we have a lower metric, its scope was smaller, so it was routing out through that because the net mask scope was smaller. And so the way you defeat that is let's match its scope. So that's why in this instance I also set our option 121 to get to that /1. And that then allows us to win in that race condition of which interface is the highest to be able to get the highest priority. And so next we'll see a trace route where we now do a trace route out to Google, and we're seeing that it's jumping out to 192.168.1.8.1, which is in fact bypassing the VPN because now that is the lowest route in the routing table. So where are we at now?
So real world implications of this. Basically, it can be widespread anywhere in a public network. If you own your own corporate network, you have ability to mitigate this, to do authentication, 802.1x, different things like that. But you can also search for exfiltration of sensitive data. You can monitor. You have a better option. When you're on a public network like SAINTCON or RSA conference or whatever, and you're running a actual VPN and you expect it to be safe, you need to double check it and you need to make sure. So we're now at the section of demo time. So we're going to make a couple changes here for just a second. And then if everyone's participating or anyone's participating, and then one of the things to note is that Android was never affected by this simply because it doesn't respect option 121. It just ignores it. So
they were lazy and they got to option 100 and we're like, nah, we're not doing any paths here. All right. So in this instance here, I just wanted to show you quick. So our little makeshift pineapple, because I couldn't find my pineapples that I've got up here, it's running OpenWRT, which is what the Hack5 pineapples do. So whatever I'm doing here, you could literally copy and paste and make it work on your pineapple or your other OpenWRT devices. So the first thing that you're going to do is you're going to go ahead and add into your pineapple is configure your DHCP LAN request. Here, we'll just show you what the whole file looks like because that's more fun. And inside of here, you've got a bunch of different network configurations. So you've got can everyone see that? Are you guys okay with that in the back? I saw one hand. Everyone else is probably asleep. You guys are talking about RFCs. Get off stage. And so we've got some basic settings here for the way that this is set up as a router. And in this instance, we're looking at our DHCP LAN config, and we're going to go down to our list DHCP options. So there's the option 6, which Fink talked about in the beginning. That's option 6 allows you to force the DNS server to be set as part of the DHCP configuration. And so that's where I was able to force a client that now joins this network to go through Google DNS. Or I could have that be a rogue DNS. I could have it whatever. I just use Google because it's super simple. And then the next option is where we're actually setting that DHCP option 121. And as you can see in this current configuration, I've got it as that 0.0.0/1. If I do /0, it won't work at all because of my tunnel adapter will go and be slightly less scope. And so it will win in that race condition. And then I've got it redirecting through the router because that's actually where I'm tapping the interface. So now that we've got that configured, restart your interface, and I'm going to go ahead and start up my VPN in this instance. And we're going to talk about specific VPN providers and what we've found of who's vulnerable and how they're vulnerable. And in this instance, specifically for this demo, I'm going to show you NordVPN. I'm using their OpenVPN connection. So if you go into Nord, Express, or any of those, and you go create my own connection and bring my own client and not use their software, because who knows what sort of bloated crap's in their software. I like to just use open source tools as much as possible. So I'm going to connect to NordVPN. This is using US server 10422. We'll get connected on this guy. And then at the same time, I'll get another command window open here so you can see what's happening on my route table. So you can see that the route got installed here. And here's the one for my VPN, VPN adapter. And we can look up here and verify those based off of their interface number. Oh, Windows, you are the worst. I'm so sorry I'm showing you this on Windows. But anyways, trust me, bro, it's right there. It's all good. It shows the data. So now that we've got that, we should be able to do like a ping yahoo.com. And then let's do a trace route, because you got to do trace route, which will take like 10 minutes. All right. So anyway, so yeah, so you can see that it's going through there. If we go ahead and eliminate that config, we would then be able to then route back through our VPN. We can see that our VPN is still green, so we are subverting traffic through here. All right. So with that in mind, we can then go to vulnerable websites, because who doesn't love going to vulnerable websites? So, and seemingly Firefox this is one of the cool features about Firefox, is it lets you go to more vulnerable websites easier. So we can visit vulnerable website here. We can go to the original website, the home of the very first website, which is not encrypted and won't ever be encrypted, because they're like, no, it's the first website. It's going to be in the original state it was in when the internet was first set up. So now we've got all of these. So now over here on my capture system, we'll be able to see anything we do in clear text. So it completely subverting the VPN. Granted, you're like, oh, there's SSL and everything's encrypted and everything, but there might still be things out there, right?
Yeah. Imagine your corporate network. You have an employee that's out. They're at a coffee shop, McDonald's, Delta Wi-Fi, whatever, and we're subverting their VPN. Any unencrypted traffic that you may have on your corporate network would remain unencrypted. So you're counting on that VPN to tunnel that back. I can't tell you how many times in our work we do find traffic on networks in corporate environments that's not encrypted. We find traffic that the passwords and the credentials are passed in plain text. And so enterprise are dependent on these VPNs to protect their corporate assets, but it's that employee that's on the go, on the travel, that's using the VPN. So we've become severely dependent on VPNs, and sometimes we don't think about the traffic needing to be encrypted inside the encrypted VPN tunnel. So those are things you want to think about. Go back to your organization. Look at, determine if you do have that traffic, what would be the risk to the business if that traffic were subverted and routed around the VPN that you have expectation that it would actually go through.
Because one thing that usually happens in organizations is it's like, oh no, the VPN's on, so trust me, everything's fine. And then it's like, oh, the center's so gooey and tasty. All right. So now we've got our wall of sheep going. It's just Wireshark. I was trying to get a whole wall of sheep thing. That would be kind of fun. But basically, like now, like, because we're just man-in-the-milling traffic and then we're subverting VPNs. I went to some vulnerable websites that didn't have SSL, so kind of throwing out some things that are there. But if any of our brave participants want to share their IP address, we can see if there's anything interesting that we caught from them. In the meantime, Fink's going to be one of our guinea pigs.
If I had my phone.
What did you do with your phone? You never leave your phone, man.
I didn't want it to ring. I didn't want it to ring.
So one thing that Fink's going to show us real quick while we're doing this, and then anyone have an IP address? 111.
We're drawing, but you go got there yet. So sorry, Mike.
Fire yours up.
You're 111?
I seriously lost my phone.
Did you go to any websites? Oh, there we go. Now it popped up. Sorry, my laptop's just slow. So real quick, what Fink's going to do. Oh, you don't have your phone?
She's going to do it.
Oh, okay. So she's calling.
Oh, she's calling my phone. It's ringing out.
Anyways, the reason why I brought up the phone thing is because we talked about Android being not vulnerable at all, and it's like legit not vulnerable. Like we verified, like we can pull it up and look in 2 seconds, and it's like, yeah, of course, it doesn't give a crap. It doesn't even try anything. So let's take a look here. We have our willing participant. Let's see if we can learn anything juicy from just an IP and scrolling real quick. So far, looks like a lot of things are protected. What VPN are you using? You want to volunteer that? Global Protect. Looks like you might be. Oh, wait. What do we got when you? Nope. Still looks like Global Protect. Everyone, Global Protect is
104.
So
there is a caveat to a lot of these providers that we're going to talk about. So many of them have a configuration where it says deny local LAN. If deny local LAN is turned on, it usually protects it and gets around TunnelVision. But that's a configuration setting that will annoy your users, right? They can't use their local printer. They can't use anything on their local network when they're connected to the VPN. So quite often we see the battle between usability and security. And that's an arm wrestle that happens in every organization. And there's always somebody with a big enough ego that they go around the policy. And so you want to make sure that you're configuring it properly. And that's what we discovered in a lot of our research is that, yes, even the big ones, Palo, Cisco, everything, they are susceptible to this if you don't have that option to disable local LAN turned on.
So, and as an aside here, one thing that's interesting is I'm just kind of scrolling through the traffic. I'm seeing the UDP, which I'm sure that's your VPN doing stuff on the back end. But then also we're seeing some TSL stuff happening back and forth. And so there might be something to be a little concerned about because I shouldn't see any of that. That should all be in your UDP streams. So unless you're using SSL, the SSL Global Protect, so I would double check that because there might be something there. Because let's say somebody slipped a certificate in now and then was able to man in the middle of that, like then we're chaining two different attacks together. But like we're able to like verify, right? Like look and verify. So this is a cool case. I'm not seeing anything here like in my 2 minutes of analysis that I'd be like, oh crap, yeah, this is broken. So, which is great because, yeah, that's awesome. Good to know. Thank you for our first willing participant. Anyone else want to be a willing participant? Huh? 164? Let's see if I can remember how to internet. 164. So while that scans, and then, yeah, so it's kind of crazy. And this is what every one of us should be doing. It's like, do you really trust your stuff? Do you really know that your VPN's working? Because there's been plenty of times at Black Hat where, you know, big XYZ vendors like our VPNs are amazing, not to name and shame, but you can listen to Bart and Grifter's wrap-up talk every year.
Trust and verify. And preach that all the time.
They're like, no, my VPN's connected. See, I got the little thing. But people get confused about split tunneling. People get confused about their configurations. Like, networking's hard. Like, we talked about some very basic stuff of DHCP, but like people still get it wrong all the time. All right, let's see what we got here. Doing it live, folks. We're doing it live. This one looks pretty good too. I'm seeing a lot of WireGuard. So WireGuard, I already know is secure. So yeah, 164 WireGuard. Who's your VPN provider? Surfshark. So, and you're using the Surfshark client? Yeah. So 100% Surfshark client has been patched and protected. So using some of those clients are good. However, you want to make sure you have a kill switch because sometimes there still might be a situation if you don't have the kill switch enabled, it will go ahead and dump traffic over. But yeah. As soon as I see WireGuard, I'm like, yeah, we're screwed.
I think we had another hand willing to give us IP.
Yeah, IP. 143. Isn't this fun? Like digging into packets. I mean, I would like to see usernames and passwords up here, but I mean, it's even better to be like, okay, no, this stuff actually works, right? Like this is actually secure because part of our job is like, yeah, like look at this vulnerability, but it's like, but what is the actual risk, right? What's actually happening? So I appreciate you guys participating in this fun little activity. All right, let's see. I'm not seeing anything from 143.
And you're on one of the three Wi-Fis. We had Delta Wi-Fi, Starbucks and Leahona.
Yeah.
What we have?
Oh wait, it's still scanning. Hold on, it might not be done yet. It just might be slow. Nope, I don't have anything on you.
After storage.
Yeah, faster storage, faster connections. Should have brought a better system. So
This is one of my lab laptops. It's at least 5 years old.
let's just, for funsies, let's just take a look and see what sort of clear text DNS we have, because sometimes DNS, even though like all of your traffic's encrypted, that might like leak some pieces of information out there and give some hints as to where you're going. And might be interesting. So Office, people are obviously using Office. What else do we have? Anything yummy in here? Not really. Oh, there was something interesting. People, oh, that's Google APIs. Man, why does Google have like 1 billion domains? And 99% of them are for ads.
Why?
Oh, Apple. I saw somebody has an Apple. There's an Apple in there. Oh, wait. I thought I just saw something that shouldn't be put on a screen. It's always fun scrolling through real fast and seeing. Live data analysis. We're doing it. All right. I'm not seeing too many things there. Let's go ahead and just do one more poking around in this little bear here and see if we have anything. Just all the unencrypted ports. So we're going to look at 80. Oh, I just clicked something. Do you know how in Wireshark, once you get a big file and you start like filtering and then you click something accidentally and it breaks everything? I just did that. Cool. Okay. It might take a minute for it. It's resorting. It's resorting the data. This doesn't have enough RAM for it. Why don't we switch back over to the other thing and I will just shout out what I see from that. I'm surprised that plugging and unplugging works so well. But great job, AV team.
Why that comes back up and he gets that. We'll go on and talk about a couple other things real quick. So there we go. We got the right. Oh, so while we're doing the research on this, I happened upon yet another DHCP manipulation technique called DHCP coerce. I did a Google search for some images that had to do with coercion. They were all super violent. There was a lot of beating, stuff like that, except this one. And this is an album called Coerce, and I thought, well, that's at least better than showing beatings. But this one's really interesting. So this is performed inside of a network. If you're on a corporate network and you are able to perform these DHCP spoofing and everything techniques, you actually do a bit of trickery and download some files and push some files and everything. But in the end, if DHCP is running on your domain controller, you can get domain admin through this technique. So nice little tidbit, and this will be the next proof of concept that we work on next week. So I think
this one was mine.
Yeah, this one's you.
So then, like, as we saw today here, it's kind of difficult to attack some of these different apps, and they've done patches. But so how do we amplify this? How do we find a way to attack all these different pieces? So number one is, in this instance, I'm the DHCP server, people connected willingly or unwillingly to my system. In a lot of instances where you're a rogue actor, you're not going to be able to have access to the router, right? So the best thing you can do as an attacker is you exhaust all your DHCP, all the DHCP leases. So a lot of networks will be like a /24. So they have 255 hosts that it can be on, or 254 hosts that they can be on there. And this will just take all the leases available. And then what happens when that's done? The DHCP server's like, we're done. I'm done for the day. I'm checking out. I'm going away. And then you stand up your rogue DHCP server, and then you can just start handing out addresses. So there's a GitHub address there for a super simple Python single script that does DHCP starvation attacks using Scapy, which is freaking rad. So super cool. Check that out. That's also just fun to denial service your friends, you know?
Go to their house, connect to their Wi-Fi.
And then, and then the other thing to do with this is just be the man in the middle and get to people to connect to your device and then That way you don't have to do a starvation attack. And then the other thing, though, is you need a client. If they already have a DHCP lease, you need to kick them off of that lease. So one of the most effective ways to do it in Wi-Fi is with DAuths. So that way you can force them to reconnect. And in that instance, there is the chance that you can get them to connect to your DHCP server. And in that instance, you want to continue to DAuth them until they get the IP you want. So so there's some kind of fun ways that you can amplify this and attack more things. So let's actually go on to the next slide that we will talk about the enterprise VPN providers, for which we have talked about how they're affected, and we've done a little experimentation today. So
through both experimentation and research, we did determine that these clients are affected if improperly configured. So we mentioned blocking local LAN access, a few other things. So you want to check and test your configurations. You may have a client that is affected, but it's mitigated by another circumstance, or it could be just vulnerable completely. So always trust but verify.
Before we go on here, a couple ones that I want to just point out was with Checkpoint. I don't know if anyone has Checkpoint, because I would really like to do a live demo at Checkpoint, because they said that they're not impacted because their tunnel adapter doesn't implement option 121. But their tunnel adapter isn't getting DHCP from the DHCP server that's causing the route to be added. So that's they're like, well, it's not in our software, it's not impacted. So I'm like, that's completely missing the point. It's the operating system that's getting the route, not your tunnel adapter. If we could manipulate your tunnel adapter, we'd be onto a completely separate vulnerability. So it's kind of funny. So anyone Checkpoint, any Checkpoints in here that want to volunteer? Yeah, so I'm super interested to try out a Checkpoint, because their response was very bizarre. It's almost as if they had no idea what this actually did. So I just wanted to point out that one.
Does she got that third?
Noted. To the vendor hall we go. I need all of you to come with me. And on the commercial side, I just wanted to point out we saw Surfshark definitely was protected with the Surfshark client. However, they do allow you to do independent configurations. Also, this could be configured on your router, because you can do your VPN connection and configuration directly on your router, so you're not using any of their software, and those typically use OpenVPN as well. So in those instances, you need to make sure that you have routes configured, you're paying attention to where your configurations are going, and who's your upstream, what's upstream from you, because pretty much everyone that I've gone through, there is a way to make these vulnerable. Typically, if you're using their clients, though, at this point, they are protecting you. They have put patches in place with the mitigations and safeguards. And then also, too, just putting it out there, OSs, as far as OSs go, we talked about Android is just completely not vulnerable at all. So if you've got anything running on Android, you're just going to be completely safe. But there's definitely instances inside of Windows, Mac, iPhone, and also Linux where you can manipulate this vulnerability.
So how do we mitigate this? We've mentioned a couple of ways: check your configurations, stuff like that. But also in the enterprise network, you can look at DHCP snooping, check for rogues, all this stuff we should be doing anyway. But all of these things all help. And as I've already mentioned, encrypt everything. Even if it's going to pass through a VPN tunnel, make sure it's encrypted from the server to the client.
And one thing, too, that is interesting that they do for mitigations, cyber is hard, is they also will change the metric of the tunnel interface now. So a lot of VPN providers will try to get as close to 1 as possible for their metric for their interface. So that's been a mitigation they've put in place as well.
Awesome. We want to thank everybody. We do have maybe a few minutes for questions. So if anybody has questions, or if you want to test, if you want to connect, we can do that.
Thank you. Also, real quick, just want to do a shout out. We have a pop-up hackerspace called Hack in the Box. That's tonight, tomorrow night, and Thursday night. It's over in the Hyatt. There was a LAN party there last night. Tonight, we're going to do a little bit of a LAN party. We're going to have soldering stations, and just come hang out. There'll be some snacks and food and light food and drinks. And yeah, so come hang out and have some fun after the conference if you want to come. So questions, comments? We have a few minutes. I see a hand.
So if someone started running with the black hat, how do we detect it?
With the same mitigation steps that we said. So first and foremost, the black hat, you have to remember that we always run host isolation. So no host can talk to another host at Black Hat.
Unless it's me.
Well, there is a caveat to that. So if you're in a training class and that training class requires the students to attack each other or to attack a resource on that teacher's network, we do open that up, but it's sandbox. And so those attacks can't go out into the rest
Other classes. Yeah.
They can't attack from one class to another. So we mitigate all of that. We also have millions of dollars. Like, we have an unlimited budget, right? Because everybody's like, here, play with my stuff. And so it's a unique environment, and we have everything. We have monitoring. We have, you name it, and we do it in layers, and we have automation.
And frankly, if somebody was doing it and we saw that it was happening, because we'd see DHCP requests, we'd see DOS, we'd see something, and if it was interesting and they were being successful, I think we'd probably let it happen, frankly. Like, we're like, damn, what did they do? They're bypassing something, and then we go find them and then say, teach us, or we'll do bad things to you.
Yeah. So, any other questions?
There.
Yeah, our talker that initial vulnerability, but where it done at the early start. You guys?
So the question was that in iOS, there's a situation where the session after it bounces may continue to have the vulnerability persistent across other sessions. And yes, I have seen that. Actually, Windows does a similar thing too, because what's happening is your routes are getting cached, and until you flush your routes, so it's a very similar thing to that. So the best thing to do is turn your interface off and turn it back on. Literally turn it off and back on, and then it's going to flush those routes, because those routes will stay for a long period. So even if you were connected to some hotspot, you walked somewhere else, you may still be infected. Your routes may be jacked up. Or if you have Starlink actually provisions their internet by using option 121 for the routes that you get. So Starlink's already planting routes in your system through this mechanism for like legitimate. That's how they do their service. So, but yes, I have absolutely seen that. Other questions? Where are we at? 420? It's 420, everybody. We made it.
All right. Thank you.
Thank you so much.